This panel is about macro and micro trends in big data with Hadoop and open source. And let me introduce the series of panelists that we're fortunate to have here today. I'd like to start, please, with Jay Raghunathan from Cloudera. He's the Senior Director of Product Management. And Ofer Mendelovich from Hortonworks, the Director of Data Sciences. Som Acharya from Altascale, the Head of Applications Engineering. Sandy Rizzo from Cloudera, a data scientist there. And Sungwook Yoon from MapR, a data scientist from MapR. So thanks everybody for joining us today. And I want to start off by asking an introductory question. How has the scale of data that's been collected by people in this space affected you guys over the last year, and where, what sort of storage and analytics requirements has been changed by that, and where do you see it going kind of in the future? So,
sure. So it's interesting because most people think about Hadoop, especially with respect to very large volumes of data and petabyte scale clusters and so on, and that definitely happens quite a bit. But we've been actually finding that on the analytics side, oftentimes the scale out factor is not necessarily storage, but compute. So for example, I think Sandy was working recently on some Monte Carlo simulations, for example, and the data sets involved were not like tremendously large, but a 100-node cluster would still take many hours to process like a good simulation across that data set size. So while people tend to think of scale on a particular dimension, specifically storage, we find that the ways in which people use Hadoop for analytics is not just gated on one dimension like storage. We've seen this across memory, across storage, as well as across compute based on the kinds of analytic needs a particular application needs. I don't know if any.
Great. Any other thoughts on that? Other vendors? Yeah, Ofer.
Sure, yeah. So I think I agree that there's a lot of both large data but also large compute applications. One of the things that's interesting is that we have a lot of new data types, like sensor data, log files, things like that, audio, video, that's coming in. That was not a really good place to store these things in enterprise, and so we see a lot of people using the product, Hadoop, the Hadoop ecosystem for processing those types of loads and those types of data sets. The other thing that's happening is Hadoop becomes a centralized place for a lot of silo convergence of data sets. So it's an interesting thing because in enterprise you have typically a lot of different data sources all in different places, owned by different people, curated by different people, and the ability to have them all in one place, specifically for me as a data scientist, is really powerful.
So, to that I would add, in the context of having multiple data sets, for instance, in one big Hadoop cluster throws up the additional challenge of determining how best to share amongst multiple groups. So multi-tenancy, being able to share a Hadoop cluster and setting that stuff up, and how to have these groups be nice to each other when running on the same cluster in terms of resource usage, and doing their own computations on their own SLAs. So that's something we do see as well.
Great. And on the analytics side, the two data scientists at the end, any thoughts on how the increase in data over the last year and over the next year, what do you anticipate? What sort of challenges are going to come out of that?
So I don't know if this is answering the question directly, but I think an interesting thing is that as the scale of data stays the same, as tools become better, like easier to use, people will be more willing or are more willing to use big data tools on more medium-sized data where they might previously have downsampled and pulled into a tool like R. So in a lot of situations, scale isn't increasing, but using large data tools on medium or not huge data is becoming more viable.
Right.
So on my experience, some of the demand is coming from in-memory processing. In fact, if you have a Teradata or whatever data you have, running analytics on that size is kind of solved, but it takes time. If you run Hive query, it takes like days. But people find it very useless if it takes days, let alone hours. They want the answer like minutes. So, then there, I think the analytics side, the in-memory processing, or anyways, real-time, close to real-time processing, we need, I saw many demand from customer side. So that's kind of trend now, I think.
Sandy and Ofer, would you agree with that sentiment, that people are getting less patient to wait for workloads to finish?
I think people are always impatient. I mean, yeah, I want to get my thing done, but I think there is the reality of that people want to take advantage of larger data sets. It's out there. I mean, we know that Google, Yahoo, Facebook, all the eBay, all the big companies have been doing it, have shown all of us that applying these data sets that are really large to their business allows them to change completely their industry. So I think you see that replicated in every kind of vertical, every kind of industry right now, and people are they recognize that using these larger data sets allows them to gain a competitive advantage, and therefore they want to do it. So using those data sets doesn't necessarily mean that ultimately, those are the raw data sets. Ultimately, when you run, let's say, a predictive model, your data set might not be that large. But they want to incorporate other types of data to create better features or better ways to create their models.
One other thing I was going to add to that, when you do run in terms of performance and speed, to me, it's not so much the absolute performance that matters as much as the time scale you're dealing with. So when you're dealing with experiments which take multiple hours, you're much more cautious about the number of experiments you're willing to take because it just consumes a larger portion of your human life. Right. And you want to be very cautious about those kinds of choices. So on the other hand, if an experiment takes the time it takes for you to check out Facebook for a few seconds and come back on, you're much more likely to be willing to be much more experimentative. So I feel like that's actually an opportunity which people are capitalizing on, and that's the sort of timescale difference that really matters. I don't think it's necessarily a fight for like 2 seconds versus 3 seconds. It's like 2 seconds versus 20 minutes. It's like a huge difference, which has been one of the things that have been enabled by some of these scalar technologies that we're talking about so far.
Yeah, I mean, to add to what Jay was saying, I think the speed of data science really is like the speed at which you can try a bunch of new things. It's not about impatience and like personal preference of not wanting to wait around. It's like if you can bring a process 10x down, that means you can try 10x new parameters or 10x new algorithms and approaches.
So to that, I think I would add, what we see from a tool standpoint, right, is a couple of years back, Hive was kind of the reigning king of like doing SQL and Hadoop. But of course, we all know Hive took a long time to run queries. It wasn't necessarily the most optimized. And so what we're seeing is an emphasis on more responsive tools like Impala and Spark on SQL. Right, so these things we do see, and Hive, of course, is responding with the Stinger initiative from Hortonworks. So that's kind of an interesting trend as well.
Okay, sounds good. Let's switch topics a little bit. Can you guys, maybe each of you, say a few words about trends that you specifically see in machine learning and data science? And let's start with you, Sungwon.
Well, I am by training. I've seen a lot of. I've read a lot of papers, from early 2000s about machine learning, ICML, JMLR. The trends has changed dramatically over the decade. It has been like before, ensemble learning, that's the king once. But the optimization and numerical analysis has took over the machine learning now. That trend has not changed yet. Basically, the big matrices and optimization on them, I think that's still a huge topic. That's because that gives you really business value. My personal thinking about that is, one downside is there's really not groundbreaking new ideas are coming recently. It's been a bit static in a sense. It's mostly how to optimize from 95% to 95.1. Yeah, that's great. It's hard. It's very, very hard to do that.
Ofer, do you agree with that comment? Or?
Well, I want to say two things. One is, you see the sea of algorithms that exist in this world, and sometimes people say, well, neural networks and GBMs and this and this and the other. I agree in the sense that I find my experience has been that finding the right features is actually much more valuable than doing anything else. And that's why I think that there's a huge, the influx of being able to pre-process huge streams of new data and allow them to come as even one more feature is much more valuable in your experimentation loop to doing anything else. On the kind of the research side, one thing, people talk a lot about deep learning, and that's an interesting topic and so on, but one of the things that for me is very interesting is to see how the community, 10 years ago, nobody really cared about big data that much, maybe aside from a few Bay Area companies. But in the research community, it was more or less, hey, let's optimize on 1,000 instances and blah, blah, blah. But nobody thought about even creating algorithms that were distributed. Now, but there was no reason it couldn't be done, but those algorithms don't lend themselves automatically to being distributed. So now, I think there's a famous paper by Andrew Ng and a couple others that sort of set the stage and said, all these algorithms don't have to be assuming that everything is in memory. And then there was a spear of research activity that comes and create things like ADMM and other techniques that are starting to pop up, decision trees that are distributed, things like that. And all of a sudden, we got a new wave of innovation that allows you to really, really distribute machine learning into distinct data sets and learn on really large data sets. To me, that's really exciting.
I think the notion of bringing so for the longest time, data science was really restricted to people at these companies like Google and Yahoo and so on and so forth. So the trend we do see now is really bringing data science to the masses, and that means again, for the longest time, the algorithms they were locked up in toolkits like Python, right? And R, and didn't lend themselves well to being distributed, as you point out. So just the advent of Spark and H2O, I think, is a massive kind of allows us inflection point in the adoption of these kinds of techniques.
I want to say, I rarely agree with anything that anybody at Hortonworks ever says, but but having said that, one thing I do want to strongly point out is what you said earlier about feature engineering and how, while we talk about different analytic methods, like feature engineering still ends up being the heart of many of the problem solutions that people are dealing with. For example, I don't know, we were talking to like a customer recently who's doing some medical analysis type application, and they're like, hey, we can do all kinds of interesting methods, but I really just want to do logistic regression because it's very easy for me to explain to my doctor why a particular result is being shown for a patient, because I can take this doctor's knowledge and encode it in features that we create and construct. So while there's lots of interesting new techniques and methods, still a large majority of what is actually being done is k-means and logistic regression at the end of the day. And I don't think that's going to change anytime soon, at least. Because they're actually pretty good techniques, and they have some nice properties around being able to explain what they're doing and so on and so forth.
So one of the reasons is actually other algorithms don't scale well. There are many complex algorithms that does kind of well for a small data set, but doesn't scale well and actually fall flat for large complex data. So that's why feature engineering is quite useful. Once you have a good feature, then you have a reasonably strong, logistic, regression algorithms that scale well, and then applied to large data set. So that's kind of a problem for some of the data science. When you go to a new field, you always hunger for a feature. What is the feature? Feature. Right. And what are you doing for us?
Yeah, to add to what Jay was saying, and everyone else pretty much, it's not just feature engineering. I think a lot of what's new and exciting is just sort of a more holistic focus on the entire data science workflow. It's not just features then algorithms. Having tools that allow you to sort of do all of those at the same time and create pipelines that you can tweak is really powerful and improves the speed of iteration.
Well, I mean, as regards the scalability and the being able to distribute and parallelize algorithms, one of the things we've been seeing is people use, say, big clusters on big data to really shrink down the working data set and find features and then get it to the point where you can actually get it to run on a single, say, very large box, right? So it's an interesting workflow.
Great. Let's shift gears again. Let's talk a bit about on-premise versus cloud, and maybe we can start with you, Som.
Yeah.
Can cloud solutions replace an on-premise deployment entirely?
Well, I mean, obviously we're biased, right? Because we do Hadoop as a service, it's in the cloud. What we do see, and when people ask us about on-prem versus in the cloud, we'll say, well, where are your machines located? Where are our machines located? It's really the same data center, right? I mean, it's Equinix or it's BAIS or wherever else it is. But that being said, we do understand that there are security concerns, right? There are compliance requirements like HIPAA and SOX. And so companies, especially if they're in health or defense, have to be cognizant of that. And so for them, on-prem still seems to be the way they're preferring to do it.
I see. What about the other panelists? Do you guys see cloud deployments of your solutions?
Yeah, I would say, again, we see a mixed things, and I think I agree with Som here. The main challenge for cloud is, the main advantage, of course, is scalability. What do you call it? You can grow it and shrink it as much as you want. Elasticity. Thank you, thank you. And but you have to solve security. You have to solve compliance. You have to solve a bunch of other situations that you cannot. You have to overcome these. You cannot move forward unless you overcome those. And I think the industry as a whole and the ecosystem as a whole will overcome those over time.
What I have seen for sure is that there are certain workloads that tend to be very amenable to the cloud. I think a modeling exercise is a good one because you don't necessarily have to have that continuously running all the time. So it takes real advantage of the key tenet of the cloud, which is you can bring it up and bring it down when you need to. A lot of people will find that when they're running continuous jobs, they don't like the pricing model of, say, an AWS as much because that shit is expensive. But when you're doing these like on and off type situations, like one of our first Spark clusters was somebody who wanted to do some kind of modeling exercise, and they wanted to try it on a really large data set, which they happen to have sitting on S3 or whatever, and they spun up a 1,000-node cluster for a few hours and shut it down. And I could have paid for that myself. It's not a big deal.
What about you guys, Sandy, Sungwook, as practicing data scientists? Do you find yourself using cloud as a substitute for local machines?
It's not my opinion. I've talked to I'm channeling my colleague, who's a more data engineer who knows this stuff pretty well. His opinion is this: if you are doing a lot of prototyping and testing, cloud is a better solution. But if you want to get the best performance out of the same number of nodes or same number of hard drives, then bare metal is far better than cloud service. That's my colleague's opinion.
I'd say I have nothing intelligent to say about the cloud.
Fair enough. Okay. Did you have a final comment on that, Som?
Well, cloud deployment technologies, right? We can have any length of discussion on the various virtualization technologies that are out there. And I think VMware and companies like that will go to great lengths to show that maybe you don't lose as much performance versus bare metal, but obviously they have vested interest, right? All I can tell you is we're really bullish on Linux containers and Docker, and feel that the overhead will be minimal that way.
Got it. Once again, let's move on to the next topic. So, in memory, it's a huge trend. Clearly we're here at H2O World. People are believers of in-memory solutions. Are things like Spark going to just completely replace a Hadoop environment in the future? How do you feel about the batch orientation of Hadoop versus the interactive orientation of Spark, and what does the future hold there?
I would say that in-memory covers a lot of different things, and it's easy to conflate them under the in-memory umbrella. If HBase is an in-memory system which has totally different uses than systems like Spark. I think from a data science and from the processing perspective, which is what I'm most involved in, big data processing is finally catching up to processing that you could do on your single computer, where you think about, where you're able to have this abstraction of loading data up and working on it, and then throwing it away when you don't need it anymore. So I think that abstraction is really powerful, but it's sort of separate from a lot of the other types of in-memory stuff that we talk about when we talk about in-memory Hadoop.
So,
yeah,
I was going to say, there's a couple of interesting things about memory in general. I'm very bullish on memory. For example, if you look at, you can go to hp.com today and buy a machine with 6 terabytes of RAM in it today. I mean, I can't personally afford it, but like I know there are people here who can probably do that. We do have customers right now who are running. It's actually like, okay, if you ask one of our SAs, like, hey, what kind of node should I buy? You will probably be given a recommendation of 128 to 192 gigabytes of RAM. It's very, very common to see our customers buying 256 gigabytes of RAM. So a 100-node cluster today could contain 20 terabytes.
Yeah, we see the same thing. We encourage people to buy as much memory as they possibly can.
And we know, like, just given what's happening, like there's memory advances. Memory density is going to keep increasing for the next 5 years at least. It's pretty much visible what's going to happen from a technology perspective. So memory as a big data artifact is like pretty much a given at this point. You can hold big data in memory, and that's going to just get better and better. You can really easily imagine petabyte scale clusters not being uncommon in the next 5 years. Having said that, one thing I want to draw a distinction, we are very bullish on Spark. We invested heavily in it because of it has certain capabilities around the memory and what it can do with it. We don't think it's particularly like exclusive to Spark. The ability to use memory effectively, like there are things that are happening, some of which is being driven, for example, by folks at Hortonworks around how you can use memory in the file system, how you can use memory in, like, say, Impala, or there are many other systems which are adapting to this as well. And I don't see that as something fundamental. There are things that Spark does which are fundamentally interesting from a iterative processing perspective, perhaps. But I don't think memories that, whether it's good or bad, like Spark and memory tend to get like associated very strongly together. I don't feel like that's actually a necessity. That's my personal opinion, at least.
I would say, I mean, to me it's very simple. When Hadoop started, when I was at Yahoo, Hadoop started in 2006, memory was much more expensive than it is today. And maybe the typical machine you would get had 8 or 16 gigs in it. And that's laughable today because I have more than that on my laptop, right? But today, yeah, it's typical to buy machines on data nodes on a cluster that have 128, 256, whatever. You can also buy a machine with a half a terabyte and use R and Python on it. It costs you probably, I'm not a hardware expert, probably 10 grand or something. I mean, it's not really expensive in the overall scheme of things. And so we will see a lot of things across we'll see it on the file system, we'll see it on the Yarn, we'll see it on Spark, we'll see it on a lot of layers in the ecosystem, a lot of products, HBase. We'll see all these things take advantage of this relatively low or inexpensive memory infrastructure that's becoming the reality of everyday life with people implementing Hadoop.
Well, yeah. So I think there's been a lot of good discussion on the memory side. So I won't really add any more there. But the second part of your question was on the survivability of Hadoop, right? And how well it will do. And part of that really depends on whether Hadoop can branch away from MapReduce and how well Yarn does, right? In kind of absorbing and producing a lot of other execution frameworks, such as Spark. So we have Spark in Yarn, for instance, and let's see how well that does in the versus, say, something like Mesos. Right.
Definitely. How many of you are Spark users, just as a show of hands, versus Hadoop users, or both, maybe? Both, yeah.
Well,
both, yeah.
I mean,
Is everybody both now? I mean, are these environments kind of just blending in a way that you can't tell one from the other?
We don't actually see them as separate. Like, there's no customer that, we have dozens and dozens of customers who are running Spark, and almost all of them run it in conjunction with MapReduce or some other framework. It's never done in exclusivity. I've never seen that happen, actually. So it'd go much stronger than that. It just never happens that you run only Spark in our environments, at least. And
yeah, I agree with that. I think Spark is one type of processing paradigm that runs on Yarn, and it's got its use cases where it's good for, and people run it together. And I'm always, I always tell people just use whatever tool best solves your problem, really.
Yeah, good advice.
Just to add, I mean, yeah, Spark on Yarn isn't something that we need to like see whether it works out. Like we have probably 40 customers running Spark workloads on Yarn, playing around with it, or doing production stuff. So at this point, like Spark on Yarn is sort of proven, and more generally, it's proven that Spark can like do great inside the Hadoop ecosystem.
Okay. Going back to a different topic, so Hadoop, historically has been identified with batch processing and doing things kind of offline. Do you see a shift or a trend towards streaming jobs and wanting more real-time applications from your customers and people that you work with?
Yeah, absolutely. I think the trend is towards, I think the latest buzzword is Lambda architectures, right, where you try to blend real-time versus more offline work. So from that standpoint, we see an emphasis on processing events, on tools like Flume, and really Kafka. So Kafka, from that standpoint, is gaining a lot of popularity. See that?
Yeah, I would second that. I think we see a lot of interest in streaming jobs. And again, as another type of processing paradigm on Hadoop. And again, because a lot of the data is already on Hadoop, things like Storm are very important, very interesting
absolutely.
there.
Yeah, we actually have a lot of interest in people doing real-time predictions in environments like Storm and Kafka, and so definitely we're seeing that trend. Jay?
For what it's worth, I'll be the naysayer here in the sense that I hear a lot of interest. I see very little real action. Okay, like people talk about this all the time, but I've not seen too many folks who actually take this all the way through. I don't want to mean to generalize this too much. There are definitely people who have done this, but to me, I feel like it's like the beginning of the hype cycle, and there's a ways to go before it actually becomes like prevalent. Part of it is honestly just the skill set requirements of making one of these things go into production. None of the streaming options out there today are particularly easy to use, and it's been a big limitation when I've seen people do pilots and they really struggle to get one of these environments up and running at high volumes. I'm sure as the tooling gets better, this will become more accessible. People will do this more commonly, but right now, at least, I still see it as a bit of a niche, which has a lot of interest.
I see. Sangwook, any comments on the real-time versus batch application direction?
We see a lot of question from customers about the streaming ability. Some of the thing I was kind of thinking a bit weird is that when I thought about, listened to the use case, many of them don't need real-time processing. So like, how fast do you want to process? And like, hour. If it is hour, do you really need streaming, processing? That's one thing. Some of the companies, for example, that need, I think they need real-time processing is bank securities, fraud detection. And even in that case, you don't really need that fast reaction. So you have, while there is a clear interest out there, do they really need it? That's something that needs to be think hard about.
So I will speak for some of the customers that I've spoken to in the past, and they definitely want predictions to be really, really fast. So if somebody swipes a credit card, you have a very limited window to figure out what to do there, and so there's definitely that aspect that we've encountered.
Certainly, but I think there's often a conflation between like having a server up that can like process requests really fast and needing some sort of streaming service that needs to like pull data in and do like more of a complex flow. So yeah, I mean, there are like, I don't know, we were trying to categorize this recently, and there's like 5 different like levels or layers of the way people need real-time processing. I would say like Spark and Spark Streaming are sort of my mandate, and like I'm often assigned to like help people use them. And half the time that someone asks me about it, my like job is convincing them that they don't need these tools because they just really don't. Even though I would love to implement some cool thing that uses them.
It's probably because they want to tell their boss.
Oh yeah, no.
That, hey, I'm using Spark. Yeah. We're with it.
Right.
That kind of stuff.
Spark streaming versus Storm versus Kafka. Any thoughts or insights there from any of you guys?
Not versus Kafka, because Kafka ends up feeding both of these systems. Yeah. So I think Kafka is a common source of data for both these environments, and so we see them all in conjunction a lot.
I mean, I would say Spark streaming is probably much more recent, right? And Storm has been around for, at least relatively speaking.
That is just factual right there.
You can still say it. Yeah, I think the same. I think there's a bit of different in maturity, but you know, Storm has been around more.
Okay. Next question. So, 10 years from now, when Hadoop is discussed in a Harvard MBA course, what are people going to say about it? Are they going to say it was a huge gain in productivity? Are they going to say it was a huge waste of money and resources? What are your thoughts on that? Why don't we start with you, Jay?
Waste of resources. I hope not. Because you're just making my life meaningless. But you know, I'm not really sure where things will be 10 years from now, but there's still a lot of COBOL around here, so I'm guessing that Hadoop is still going to be pretty common at the time. I mean, at this point, I feel like Hadoop is in a trajectory where it's going to be, to some extent or the other, in every enterprise in the next few years. So it's no longer a question of if but when from that perspective. So I don't think it'll be out of the zeitgeist in 10 years. It'll still be something people will be using. I'm sure there won't be nearly as much buzz as there is today, which might mean not so good things for us. But I'm pretty sure it's at some point it'll be buried under a set of new applications that are built on top of it, and it'll just be something which is taken for granted.
Yeah, I would say, I mean, I've recently saw that Forrester or somebody like that said that Hadoop is not optional anymore for enterprises. So I think definitely the trend is growing. Like Jay, I don't think that I would like it if in 10 years it'll be that. But I can also say that I was there when Hadoop started at Yahoo in 2007, 2006. And it's been an interesting journey for me to see how Yahoo, from something that nobody knew what it was, and it kind of grew and grew and grew, and now they have, what, 40,000 nodes and 20 clusters, I mean, and seeing the growth in usage inside of it. I sort of feel like that same thing was going to happen again in every organization that adopts this. So I actually am very bullish about this. I think I kind of seen it once, and I'm expecting to see it again and again and again, a lot of across the world.
Yeah. What about you, Sam? When you're giving lectures at Harvard in 10 years at the business school, how are you going to describe Hadoop retrospectively?
Well, by that time I'll be speaking to batches of screens, because everyone will be off, like virtually somewhere else. Yeah, exactly. No. So one of the successes of Hadoop has been that the metaphor it provides in terms of MapReduce is easily understandable. It's a nice framework for parallelizing lots of things, and now it's moving on to other execution frameworks. So I think it's just getting started. Unless there's something like quantum computing that comes along and completely upends the entire paradigm, I don't really see anything else really challenging Hadoop for supremacy.
What about for specialized application, this specialized data science stuff, do you think that that's going to impact how people talk about Hadoop 10 years down the road?
Yeah. I mean, I like to think that in 10 years, the students in those classes are not going to be humans, but sort of massive Hadoop-based superintelligences.
Exactly. Augmented intelligence.
Right. So hopefully they'll be grateful to their creators.
Any final points on that question?
Not that I don't believe in Hadoop. I'm just, I like to say a bit of a pessimistic view. One is from a guy from my former company forwarded an article by Michael Jordan warning about winter of big data is coming potentially. So that's one warning. The other thing is my observation from my company and talking to others too. Hadoop itself has not found its own market yet. So the market I saw that we are penetrating into is storage, and mostly in the low-end storage market or kind of replacement. Did not have any chance getting into HPC market yet. So it's kind of, again, I'm trying to just, devil's advocate, whatever it is. Not that I'm really, bucking the trend, but there is something that I see that Hadoop as a whole did not create a unique market yet.
I see. So a bit of a counterpoint there to the other panelists. Does anything, just following up on that a little bit further, does anything keep you guys up at night, right? Do you see anything kind of nipping at the heels? What are you worried, if anything, about that might overtake Hadoop on the horizon?
I guess I grew up as a Hindu, and one of the things which is nice about Hinduism is it's very malleable. It adopts whatever intrudes. I suspect that Hadoop is going to be a bit like that. I suspect that the file system primitives are going to be relatively unchanging, I hope at least. And the set of frameworks that comprise Hadoop might see changes over time. I expect, today there's probably like 5 to 6 different frameworks that are the popular stable set that everybody cares about. I'm sure that set will change, but it'll roughly remain that size, 5 to 6 things which are very popular for different types of applications. But as the times change, we'll change with it. Like Hadoop will just rename itself because it's a very flexible name as it is. Anyway, that's what I hope at least.
Any other comments to that, or questions, or follow-ups?
So I will say one thing. If it's a bunch of HBS students, they won't give a rat's ass about what happened in Hadoop by then, but it'll be more about who won the Hadoop wars and who's like, much like the middleware wars, who's the JBoss and who's the WebSphere. And I'm not going to pick a winner, but if you ask me to, you know exactly who I'm going to be biased towards.
Right. What about hype? Do you feel that, a couple of you have alluded to hype. Do you think that there's too much hype around Hadoop, more than is realistic for the actual software to live up to? Any comments on that?
I think it's hard to provide perspective simply because, like Ofer, I think a lot of us kind of grew up with Hadoop, right? We were around at Yahoo or just thereabouts when it first got started. And so, no, I mean, the only other thing I would say is, a lot of the core design tenets of Hadoop came out of Google, and it's very interesting to think what so they're certainly a couple of years ahead. So if you want to predict where Hadoop is going, look at the papers coming out from Google, right? And the various research stuff that they're doing.
Yeah, I would say on your question, I don't, again, I'm biased, of course, tremendously. I think everybody here is a little bit biased their way. But no, I don't think there's a lot of hype. In fact, before I joined Hornworks, I was working for a while with a venture fund, and I was talking to a lot of different people in that context, and a lot of them asked me that same question. And now, 2 years later, I'm more convinced than ever that the answer is no.
Definitely, HDFS has really staked a claim to data storage in a lot of environments. I mean, no question that many of the people we deal with are heavily invested there.
I agree.
Slightly different question, actually was alluded to before. So what's the role of man in machine intelligence, right? When are we going to have Skynet? Sandy, why don't you start off with that one?
No role. No, I mean, we're at the point where man has an enormous role. I mean, especially, we're barely scratching the surface of like deep learning and all this stuff there. But I still think we're at the point, and I don't know if it's a bad thing at all, in which having really skilled data practitioners is important to being successful with data. And I think replacing that as you get into more like complex applications is going to be really hard. We can sort of keep like raising the water level on where humans need to be involved and think about things, but there are always going to be some new frontier of applications where sort of deep human thought and care are required for getting good results.
Other comments from our other data scientists? Can machines actually replace people in this area? Or?
I think machines are very, very good at doing a lot of computation very efficiently, very effectively. I still believe that we're far from the time. I mean, I see a lot of movies and I read a lot of science fiction when I was a kid, and clearly I like to believe that at some point we'll get there, but I think we're pretty far off still. You know, AI, as was kind of perceived in the 50s and the 60s, thought that we'll get there a lot faster than it turned out to be the case. But machine learning that came out of this sort of vision of AI, you know, with robots walking around, has created a ton of value across. I mean, it doesn't have to be that everything is completely automated, but if particular tasks are done tremendously faster and better than humans can do them, that's great. But I think there's a huge amount of value for the human input, for human judgment still in creating the large thing. And maybe in a more practical sense, I would say, if you look at, you know, how organizations use machine learning to solve real-world problems in enterprises, you know, the role of a business expert or the SME is tremendously useful still. So there's engineers who build the data pipelines, there's machine learning experts who build the algorithms, and then there's always a business analyst or a domain expert or a, you know, whatever you want to call that person, that you can create all the fancy algorithm in the world, but if it's not solving the problem that you need to solve, and it's not a business context you have to understand, then you're doing the wrong thing. So I think there's a tremendous, we're far away from that vision. In other words,
yeah,
yes.
I'll add one comment on that. If you look at some of the advances in AI, one achievement was Deep Blue, meaning the chess master by the computer program. Then is it really AI? If you look at the algorithm, it's a very brute force search with a lot of heuristics and a lot of opening and closing books encoded into the algorithm. Next to come is Watson, all by IBM. Huge achievement, beat the Ken Jennings?
Ken
Jennings.
Yeah.
Amazing achievement. I was really shocked. But if you look at the under hood, what's the algorithm that runs sophisticated algorithm? Yeah, a lot. But does it have human level intelligence? No. No, not at all. It does. If you look at where does Watson miss the question, it was a very simple question that human can easily overcome simple logic. So it's very, very far away from human intelligence if you look at the individual achievement. And here the question is whether huge data with simple algorithm can achieve human level sophisticated reasoning. That's something that needs to be answered later. I'm not sure whether that can be done or cannot be done. So that's open in the air.
Any more thoughts on that one?
You know, I wouldn't count out human ingenuity. So we are talking about, you know, we read about people applying big data to predict crime, for instance, Minority Report. So my thought is maybe in 10 years you'll have criminals using randomizers so that to kind of defeat the predictions of computers. It's already a thing, is it?
In spam, it's a thing. Yeah, they've figured out how to do all these clever things to fool. They'll send like non-spam messages that have certain terms in them to totally like fool the spam filters.
All right. Well, we have a few minutes left. If there are any questions from the audience, we can take a few questions here.
Hi. Can you hear me?
Yeah.
Yeah.
Okay. So one question I have for the panel is if you could have a processor architecture, CPU processor architecture, what would it be? Lots of cores in a dense core machine, or do you want them to be lower in core count with lots of DRAM, of course, but lots and lots of commodity machines? Jay, you start first.
All right.
I'm going to take a cue from Tom.
Make it easy, why don't you? So I won't try to be too predictive here because I'm not an expert in hardware architectures, but I will say that there are a set of, let me talk first a little bit about how we think about when to buy a more expensive machine versus scale-out architecture and so on and so forth. There are certain class of algorithms which actually don't scale out, and having a faster processor is basically the only way you're going to get better, especially when you look at the previous input for every next step. But in general, what really matters for the kind of scale-out things we're talking about is price performance. So a lot of times people will be like, well, what if you had the special part to your machine which would like give you a significant performance boost? The real question becomes, well, if I take the cost of that thing and put it to like 100 nodes, which is typically what we're dealing when we're dealing with data sets we're talking about right now, is the cost of that component added across 100 nodes a better deal than just buying the additional nodes I could have bought for that same price? That's sort of the math we always do when we evaluate hardware components. So I'm not answering your question at all, but at the same time, I just want to point out that that's the sort of calculus that always applies. One other point I'll mention is that in general, CPUs are pretty good at doing the kinds of things that we use them for. There are certain classes of applications, like image processing is a good example of something where GPUs are heavily used. There's all kinds of challenges with using GPUs effectively because the bandwidth between the memory and the GPU is not always great, so you have to be very careful about, I can push the content to GPU and run it there for a long time. Are there things that the CPU guys could do which would actually give us that kind of performance on a local CPU? Possibly. Is that the right thing to do? I don't know, because it's often tied down to that economics question.
Other thoughts on that question?
Yeah, I would say, and as wearing the data scientist hat, what I want is I want the thing to run fast on my data, and I think right? Cheaply, yes. And so it depends on my data, and it depends on what I want to run. It's very similar to what Jay said. It's like, I don't know. I don't think there's one solution, one ring to rule them all. I think it depends on your application. That's why what we see is people design their architecture and they think about it differently on a little bit in different organizations depending on what they want to do.
I didn't quite get the question. Was it CPUs versus GPUs? Was that the?
That was just me meandering.
The question was, what kind of hardware architecture would you most want for your software? Would it be lots of cores, or a smaller number of faster cores, or basically?
It depends on the workload, really. In the end, you can't have a one-size-fits-all.
I would actually throw in the environment with the best API that's easiest to use has a very good chance to win. So don't skimp on tools.
That's good point.
Other questions from the audience? No more questions? All right, well, let's thank our panelists.